All right, notes part 3. Let's take a look. So, first of all, we're looking at um, your energy meter looks something like this. You'll have one outside your house or wherever, and it's measured, notice, in kilowatt hours. All right, so we will be talking about that here. First of all, let's talk about the difference between series and parallel. We'll be getting into those in detail next week, but a series circuit is one where the resistors are connected like this, so the current has to pass through all of them. There's another type of circuit called parallel, which looks like this, and a parallel circuit is such that when the current flows, it has a choice. And not that the electrons are sitting there thinking about it, but you could have current flowing from this positive terminal of the battery through this resistor and then back to the negative terminal of the battery. So that branch of the current only passed through one of the three resistors in the circuit. That's described as parallel. Okay, more on that later. So some variations to the formula for power. We know that power, right, energy per time, is current times voltage, this PIV formula. And we also have Ohm's law, voltage equals current times resistance. So we could change this equation up by substituting in IR for V, and we would get power is current squared times resistance. We could also do the same by substituting in for I, V over R, and we would end up with this, power equals voltage squared over resistance. So both of these variations of this formula can be helpful. You really only need these two, but those are different variations. Alright, so how much energy does a heater use? If you have ever looked at your energy bill, alright, or your electric bill, which is going to be different from propane, it might look something like this. I just stole this off the internet. But notice how it's measured in kilowatt hours. And then down here you'll see, so these are the charges per kilowatt hour. And this actually looks pretty cheap. Cool. Alright. What am I saying? Oh yeah, kilowatt hours. Okay, so how much energy does a heater use? So we know that power is energy per time. So if we multiplied this by time, do you see that? We'd get energy. All right. So this is how we have a reading or a measurement of power times time to give us energy. When you use a certain amount of something from your electric bill, it's showing the amount of energy that you actually used for heaters and stoves and whatever. So power measured in watts, but because we use a lot of them, a lot of watts, we call it a kilowatt. So that's a measure of 1,000 watts. And then time, instead of seconds, we're measuring it in hours, because again, we do use lots of energy. So what is exactly a kilowatt hour? In terms of joules, we know that energy is usually measured in joules, but a kilowatt hour is sort of a bigger version of that. Just like when you measure the distance to New York, you don't measure it in centimeters. So right over here, 1 kilowatt hour, so a kilowatt is 1,000 watts, and a watt is a joule per second. That's a watt. So we have 1,000 watts, and then times 1 hour, and we know that 1 hour is 60 times 60 seconds, so 3,600 seconds. And we multiply, we get 3,600,000 joules of energy as a kilowatt hour. So again, this number is easier to deal with than this when we're talking about large amounts of energy, such as what we would use in our homes. Alright, what does a fuse or circuit breaker do? So, basically, if you have a wire and you run too much current through it, it can catch on fire or melt, causing a short circuit or causing the causing the house to burn down or something like that. So we have these things called fuses and circuit breakers. And the idea behind a circuit breaker in a house is basically it's a switch that will open when too much current passes through it. So this is a good description of what fuses and circuit breakers are, and hopefully on the next page I have an image of a circuit breaker to show you. Alright, so here is a circuit breaker panel, and so these little things here are the circuit breakers, and this, hopefully, I remember living in this place where none of it was labeled, so we had no idea what they were, and if you overloaded the circuit, so you ran the toaster and the microwave and the washing machine, all the lights would go out because one of these would open. So these little red things were like a switch, and it would open, and then of course there'd be no electricity passing through, and the lights were all on the same circuit, so in the dark we'd be trying to figure out which one of these it actually was. So this is what the panel or the circuit breakers will look like in a house or apartment or wherever, and the idea is that these are all switches to help you from overloading the wires and burning down the house. Okay, two examples. So these are from homework. Question 1 says, an electric space heater draws 15 amps from a 120 volt source, and those are pretty realistic values. It is operated on average 5 hours each day. So you get home from school, turn on the heater, turn it off before you go to bed, maybe 5 hours per day. So 1, how much power does the heater use? And so power, we're doing current times voltage. We have current, amps, times voltage, volts. 1800 watts. This is pretty standard for a medium-sized space heater. Part 2, how much energy in kilowatt hours does it consume in 30 days? So the total amount of energy it consumes in a month. So let's see. Kilowatt hours times time, remember, and then the fact that we're doing that each day for 30 days. So let's see, 18, kilowatt, multiplied, and we just get 270 kilowatt hours. How much energy in kilowatt hours? And let's see, where did I get this number? The 1.8 kilowatts came from this 1800. So we go whoop, 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 and that's 1.8 kilowatts. Alright, and 5 hours each day for 30 days. So this would be over the course of a month. And then the third part relates it to something we'd be interested in. If the energy costs 12 cents per kilowatt hour, which is, I think it's more expensive in Mammoth, how much does it cost to operate the heater each month? So if we had 270 kilowatt hours, and we know 1 kilowatt hour is 12 cents, we could simply multiply and we get $32.40. So that's, I think that's pretty cheap actually, compared to what we would be using or spending to heat our places with electricity. Okay, part 2, an automotive battery can deliver 55 amps, that's a lot of current, at 12 volts, but car batteries are designed to produce a lot of current so they can start the car engine. So 55 amps at 12 volts for 1 hour, meaning then it would be completely discharged, there'd be no energy left, and it's going to require, when recharging, 1.3 times as much. And so this is, the question says, due to its less than perfect efficiency, when a battery is running or when you're charging it, if you feel the battery, it's going to get hot. And so that means the energy is lost due to heat energy, which is where this comes into play. So, how long will it take to charge the battery using current of 0.75 amps? This is a relatively small current. In your homework, I think this was actually 7.5 amps, so your answer will be a little different. But it goes like this. So first, we figure out how many joules of energy does the battery actually store. So we know that energy is power per time, so joules, our energy, will be power, current times voltage, and then times time. So I have a current of 55 amps, a voltage of 12 volts, and then it told us that it would do that for 1 hour, meaning 3,600 seconds. So multiplying all together, we get a whole bunch of joules. Yeah, and so this is how much energy the battery stores. Second part is we know it will take 1.3 times as much energy to charge it, because some energy is lost due to heat loss. And so 1.3 times this gives us 3 million something joules, and then we just kind of work the problem backwards, where we're saying joules, current, voltage, seconds. So joules, current, voltage, seconds, and we end up with this many seconds, which is 95 hours, which is a long time. You'd be using a greater current to actually charge your car battery, and you'd be able to do it in a day.